All right, let's jump right in. Today, we are talking about something that could fundamentally change not just how AI works, but how AI is even created. We're looking at an AI that, get this, invents other AIs.
So this whole story kind of starts with a moment that, for a lot of us, felt like pure science fiction. AlphaGo's Move 37. Remember that? It was a move in the ancient game of Go that was so creative, so out there, it just completely upended centuries of human strategy. The researchers behind this new paper, they see a direct parallel. They say, and I'm quoting here, that these new AI design models challenge our assumptions and inspire us to explore uncharted territories in design philosophy.
And that led them to ask this really fascinating question. What if AI could have its own Move 37 moment? Not in a board game, but in the actual process of designing itself. What if an AI could stumble upon architectural principles that we, its human creators, just can't see? But, to really get why this is such a huge deal, we first need to talk about the problem it's trying to solve. And it's a major, major bottleneck in the world of AI research. And here's the fundamental conflict, right? On one hand, you have AI capabilities just skyrocketing, growing exponentially. It's wild. But on the other hand, the actual research, the process of discovering new AI designs, well, that's still stuck moving at human speed. It's methodical, it's linear, and frankly, it's slow. This growing gap, that's the real problem.
So how in the world do you break through that human bottleneck? Well, the answer this paper gives is it's both kind of radical and perfectly logical at the same time. You build an AI to do the research for you.
Okay, so let's meet the star of the show, AIC-ARCH. That stands for Artificial Superintelligence for AI Research. And look, this is not just another automation tool. This is a huge leap from simply automating tasks to genuine innovation. Instead of just searching through a list of options that humans have already defined, AIC-ARCH comes up with its own hypotheses, writes the code, and tests totally new AI architectures all on its own. It's designed to be a true AI scientist.
And the way it works is just brilliant. It's basically a self-contained little research team made of different AIs. First, you've got the AI researcher that dreams up a new architectural idea. Then, an AI engineer agent takes that idea, builds it, and tests it. And finally, an AI analyst crunches the numbers and figures out what happened. This whole thing just feeds back into a loop over and over, creating this massive base of experience that lets the system get smarter and way more creative with every single cycle.
Okay, so what happens when you just let this thing run? When you let this tireless AI research team conduct thousands of experiments 24/7? Well, this is where it starts to get genuinely mind-blowing.
First, let's talk scale. We're looking at over 1,700 autonomous experiments.
And the computational effort? A staggering 20,000 GPU hours.
So, what did all that work get them? 106 new state-of-the-art model architectures. And these aren't just novelties. These are designs that are competitive with, and in a lot of cases, actually better than the ones created by top human experts.
And this right here, this is the ultimate test, isn't it? It's one thing to discover a bunch of new designs, but how do they really perform? How do they stack up against the best-in-class architectures that top human researchers have painstakingly built?
The results are, well, they're pretty stunning. Take a look at this table, which we've adapted from the paper. It highlights one of the top AI-discovered models, something called Pathgate FusionNet. And as you can see, it scores higher on average than leading human-designed architectures like Mamba 2 and the baseline model DeltaNet. So it didn't just meet human performance. It flat-out surpassed it.
So here's the crucial insight. This wasn't just a lucky shot in the dark. The researchers realized that these discoveries were actually following a predictable pattern. It revealed a brand new principle they're calling the scaling law for scientific discovery.
This is huge. For the very first time, they established a clear empirical link. You can scale scientific breakthroughs in this field with computation, just like you can scale a model's performance. It's almost an equation now. The more compute you throw at the problem, the more state-of-the-art discoveries the system finds. Research itself has become a scalable process.
And this all leads us to a really profound final thought about what this discovery truly means for the future of AI.
So why does all of this matter so much? Well, for one,
What we have here is basically a blueprint for self-accelerating progress. AI research is no longer this thing limited by human ingenuity and speed. It's now a task that can be scaled with computation. And maybe most importantly, it means that the AI we have right now can be put to work designing the next, more powerful generation of AI. You can see how the process can start to feed on itself, right?
And that leaves us with this final, really provocative question to chew on. If an AI that designs other AIs is today's Move 37, what's tomorrow's? What kind of creative, unimaginable breakthrough comes next when this cycle really truly starts to accelerate?